Okay, we're focusing on chapter 2.4 now. We're talking about average rate of change of a function. So what the average rate of change of a function is, if we have a function y equals f of x, and we define between 2 points x equals a and x equals b, if we're talking about the rate of change between those 2 points, what we do is we look at the change in heights divided by the change in widths, okay? And we'll take a look at it here in this function, okay? So the average rate of change of the function y equals f of x between x equals a and x equals b is given by this formula: average rate of change in y divided by change in x. The change in y is f of b minus f of a. The change in x is b minus a. So for example, suppose I have 2 points. I have an a and a b. And I want to look at the average rate of change. So the average rate of change. Well, first thing we need to know is that this right here is f of a. That is the height of the function at x equals a. We also know we have f of b right here. So the question is what's the ratio of the change in y distances, this distance, divided by the change in x distance, this change in this distance. So distance between these two. Well, how do I represent the distance between these two? We go the full distance here minus the partial distance. That gives you that distance. So we write that as f of b minus f of a. Again, we can talk about that. That's from here to there. That's f of b minus f of a divided by this distance right here, which is the total distance of b minus the total distance of a, is b minus a. Okay. That's this, b minus a. But you'll note that this is very similar to algebra, where if we wanted to find the slope of the line between 2 points, let me get a little bit better there. So this point and that point, wouldn't we just take the change in y divided by the change in x? That is y2 minus y1 divided by x2 minus x1. Well, that's what this is. And this actual line right here, this green line, is called the secant line. And what we're doing is we're finding the slope of that secant line. The slope of the secant line, that is the average rate of change between the points a and b. Okay, x equals a and x equals b. Okay, so let's take a look at a couple examples. Okay, so here's our first example. F of x equals x minus 2 quantity squared. We're going to find the average rate of change between the following points. We have x equals 2 and x equals 3. So what we're looking for, x equals 2 and x equals 3. Here's x equals 2. Here's x equals 3. We're looking for the slope of the secant line that goes through the 2 points on the graph there. So what's that slope right there? That's what we're looking for. What's the slope of that guy? Well, so we're going to use a formula, average rate of change, which is f of b, f of 3, minus f of 2, f of 3, the height of this one, minus f of 2, the height of this one, divided by 3 minus 2. Well, the bottom equals 1. The height at x equals 3 is 1. Okay, and you can use the formula for that. 3 minus 2 is 1, 1 squared is 1. Put in 2, 2 minus 2 is 0, 0 squared is 0. And that slope equals 1. So the average rate of change between here and here is 1. All right, let's do it for another problem here, 2 and 2.5. So the average rate of change is equal to f of 2.5 minus f of 2 divided by 2.5 minus 2. So we have 0.5 in the bottom, f of 2 equals 0. And then what we need to do is put in 2.5 in for x here. So 2.5 minus 2 is 0.5. Okay, so it's 1 half. 1 half squared is 1/4. Okay, so this is 1/4 or 0.25. Okay, and if I do 0.25 minus 0 divided by this guy, it turns out to be 1/4 divided by 1/2, which is, what is that, 1/4 times 2, so that's what, 1/2? So that is looking at the slope of the secant line between here and 2.5. Okay, very good. So the slope of that secant line. Okay, next one, 2 and 2.1. So average rate of change, f of 2.1 minus f of 2 divided by 2.1 minus 2. Okay, so f of 2.1, 2.1 minus 2 is 0.1, 0.1 squared is 0.01, minus 2, f of 2, which is 0, and is divided by 0.1, which equals divided by, so I have 1/100th divided by 1/10, which equals 1/10. Okay, so I have 1/10 from here to here, so I have, 2.1, so right here, it's right there. That slope is 1/10. Next one, average rate of change, f of b, f of 2.01 minus f of 2 divided by 2.01 minus 2, 0.01 on the bottom, 0 right there. 0.01 is going to be 2.01 minus 2 is 0.01 squared is 0.0001. So that's 0.01, or it's 1,000th divided by 1/100th, which is 1/100th. And we get something like just barely, okay, right there. So we're looking at the slopes of these secant lines. So notice I kept this one fixed, and I just kind of kept approaching this way. In other words, I took this is a fixed point, and I took this secant line, and I just kind of kept taking this string that's attached here and kind of moving it closer and closer and closer. And look what the outputs come. I go 1, 1/2, 1/10, 1/100th. They keep getting smaller and smaller and smaller. In fact, the more this approaches this point right here, what we end up doing is we're actually approaching what we call the tangent line that just touches barely, which of course the tangent line to this curve, f of x equals x minus 2 squared, is 0. This has slope 0. This tangent line has slope 0. And notice that's what these numbers are approaching. Okay, and that's kind of the big picture thing that we're looking at there. So, average rate of change, f of b minus f of a over b minus a. Okay, we can look at it in a bunch of different scenarios and see how those secant lines kind of approach that tangent line. Okay, a little bit more abstract one. Suppose I let f of x equal a quotient 2 over x plus 1. And I want to look at the average rate of change in a given interval. In this case, the interval is 0 to h, where h could be any number. H is just a real number. The first thing I want you to note that I did use interval notation for this one, whereas before we were talking about from x equals a to x equals b. Well, this means the exact same thing. This means, from this case, from x equals 0 to x equals h. So if you see this interval notation like this is the first value, this is like the a value, and that's like the b value. So we go from a to b. So we're going to use our formula, the same formula, f of the average rate of change is f of b minus f of a divided by b minus a. Same exact formula. We're going to input, instead of b, we're going to use h, and instead of a, we're going to write 0 in this function here. So let's take a look. This does take a little bit of algebra for this one. So we're going to find the average rate of change. So I have f of b, so it's f of h minus f of 0 divided by h minus 0. Okay, this is my b, this is my a, b minus a. So what's f of h? F of h is 2 over h plus 1, 2 over h plus 1, minus 0, f of 0 is 2 over 0 plus 1, divided by h minus 0. Okay, well, what's that equal? Well, let's just simplify this. This is 2 over h plus 1 minus 2 over h, right? 0 plus 1 is 1, 2 over 1 is 2. Okay, h minus 0 is h. Now we need a common denominator. So let's get a common denominator between these two. It's h plus 1. So I'll have 2 over h plus 1 minus 2 times h plus 1 over h plus 1 divided by h. Again, this is equivalent to the fraction 2. Okay, multiply top and bottom by the same thing, top and bottom by h plus 1. So I can therefore subtract those guys on the numerator, and I'll get 2 minus 2 times h plus 1 divided by h plus 1 all divided by h. Okay, 2, the same denominator, 2 minus this guy. I'm going to distribute this 2 now. So I'll have 2 minus 2h minus 2 divided by h plus 1 all divided by h. Okay. 2 minus 2 is 0, so I'll have negative 2h divided by h plus 1 all divided by h. Okay. And this means, guys, negative 2h over h plus 1 divided by h. Now what that means? This fraction divided by that guy. Okay? And division, of course, means multiplication by the reciprocal. So I'll have negative 2h divided by h plus 1 times 1 over h. Those two things cancel, don't they? Right? So I'll get negative 2 over h plus 1. So this is the average rate of change of this function from 0 to h. Now what's great about this is that, we could have done this calculation from 0 to 3, and instead of h I would have had 3, or 0 to 10, and instead of h I would have had 10. But if I do it in general from 0 to h, now I can say, if I want it from 0 to 10, just plug in 10 here. I get negative 211. So if I want it from 0 to 100, I just plug 100, negative 2 over 101. Okay, so that's the average rate of change in this interval from 0 to h. Okay, it does take a little bit of algebra. Okay, and the algebra here is, getting common denominators, fractions. I know they're a pill, but once we get through that and do a little arithmetic, it turns out to just be negative 2 over h plus 1.